the normal distribution. Example 5. The amount of time spent by somebody in the library is given by this normal distribution. Is the normal distribution suitable for the given context? So we could sketch the information given. So the mean goes in the center. This is a variance. So the standard deviation is 23.32 minutes, and we're using minutes for our units. A sensible scale along here will be the mean plus 3 standard deviations and the mean minus 3 standard deviations, because we know that 99.7% of the distribution will lie within 3 standard deviations of the mean. So the value here would be the mean plus 3 times the standard deviation, 129.97 minutes. Now that seems fine. It's a little over 2 hours, nothing wrong with that. And then if we work out the value on this side, the mean minus 3 standard deviations, and that should still be a sensible value, what we find is it's a negative value. So the normal distribution here is predicting that somebody stays in a library for a negative amount of time, which is a nonsense. A good model of a normal distribution will always give sensible values along here, from the mean minus 3 standard deviations up to the mean plus 3 standard deviations. These should all be sensible values. Clearly this one is not, so the model is unsuitable. Part B. So we have a box of 500 nails, and the smallest one is 28 millimeters in length, and the longest one is 118 millimeters in length. So is this a good normal distribution to represent the distribution of lengths of these nails? So we have the mean, which is 52 millimeters. The variance is 100, and the units for variance are units squared. And if we square root, the standard deviation is 10 millimeters. So if we go 3 standard deviations above and below the mean, we should have sensible values. So we've got 22 for the lower limit and we've got 82 for the upper limit, but the normal distribution here is saying that we shouldn't really have anything that's longer than 82 millimeters, and we do. So the model is unsuitable. Example 6. So we're given a probability, and we're told that 50 observations of x are made. So in a single observation, the probability that the random variable x takes a value more than 29 is 0.92 or 92%. That's in a single observation, but 50 of these observations are made, and we have to work out this probability. So we have a fixed number of trials. The probability of success is constant, and an observation of x either gives you a value that's more than 29 or it doesn't, and this is basically the binomial distribution. So the normal distribution isn't to be used everywhere. Clearly a binomial model would be better, and we can see that our 50 observations, number of trials there, the probability of success in any one trial is right there, and find the probability that we have at most 43. This probability, here it is, probability of at most 43. So a binomial distribution is necessary for this solution, not a normal distribution. For further practice, try these questions.